Welcome to another video of Class A Subnetting. We are discussing /21 in this video. So /21 means that there are 21 bits are of the network and remaining 11 bits are of the host. So these are 11 host bits. These are 21 network bits, out of which these 8 bits are the default network bit, because we are talking about class A, and for class A default subnet mask or default CIDR value is /8. But the remaining bits that are highlighted with green are the subnetwork bits, that the bits borrowed from the host section into the network. Okay, so 8, 9, 10, 11, 12, 13. We have 13 subnetwork bits over here. Okay, now let's write down the subnet mask. It will come out as 255.255.240.0. Why 248, not 240? 248 because 128 plus 64 plus 32 plus 16 plus 8 comes out as 248. Okay, 128 plus 64 is 192, 192 plus 32 is 224, 224 plus 16 is 240, and 240 plus 8 is 248. So the subnet mask is 255.255.248.0. How many subnetworks we are going to get when we borrow 13 bits from the host? 2 to the power 13. That means 8192 subnetworks we are going to get. How many hosts per subnetwork we are going to get? That is 2 to the power y, where y is the number of host bits. How many host bits we have? 8, 9, 10, 11. So 2 to the power 11 minus 2. 2 to the power 11 is 2048, and minus 2, that means actually we will get 2046 valid host IP addresses in each of the subnetwork. What are the valid subnets? That is 256 minus 255. So increment of 1 in this octet, and 256 minus 248, that is the increment of 8 in this octet. So we will go on incrementing 8 in the third octet first. When we will reach to the point when there is no possibility of increment in the third octet, then we will do increment of 1 in the second octet, and then again we'll start incrementing in the third octet. So let's write down few of the subnetworks. 10.0.0.0, 10.0.8.0, 10.0.16.0, 10.0.24.0, 10.0.32.0. This will go on till we reach 10.0. By incrementing 8, we will reach to a point where we'll get this network ID 10.0.248.0. Now if you add 8 over here, it will become 256, which is not a valid IP address. So what we will do at this point, we will do increment in the second octet. So next IP address that we will write is 10.1.0.0, then 10.1.8.0, 10.1.16.0. This will go till 10.1.248.0. Now again when we reach at 248, it's not possible to do increment of 8 in the third octet, so we'll do increment of 1 in the second octet. Okay, this will continue till we reach the number 255. So 10.255.0.0, 10.255.8.0, 10.255.16.0, 10.255.24.0 till we reach 10.255.248.0. Now increment of 8 is not possible in this. Increment of 1 is also not possible in the second octet, because in both the cases we'll get the number 256, which is not valid, because our range lies between 0 to 255. We have 8 octets, so our range lies between 0 to 255, and hence this is our last sub network. Okay, this is the network ID of our last sub network. Its broadcast ID will be 10.255.255.255. Okay, here net broadcast ID will be 10.255.7.255. This is purely host, so you can write 255 over here. You will not disturb these two octets. You will always focus on the octet in which increment is taking place. So increment is taking place in the third octet over here. So you will write down the number which is preceding to the third octet number of the next network ID. Okay, what we'll write over here, broadcast ID of this, it will be 10.1.23.25. Okay, here it will be 10.1.255.255. Here it will be 10.0.39.255. Okay, so these are all broadcast ID of the different subnet. What will be the first valid host in this case? 10.255.0.1, and what will be the last valid host? 10.255.7.254. So while writing first valid host, you will write down the next IP address of the network ID, and while writing down last valid host, you will write down the preceding IP address of the broadcast ID. Okay, so this is all about /21. We'll be discussing /22 in the next video. So stay tuned with dNAxt. Thank you.